In this video, we are going to discuss, is this erasing? Yes. Okay, so we're going to discuss multiplying and dividing rational functions. So we're going to talk about multiplying, dividing, and then adding and subtracting. So with rational functions, usually adding and subtracting is the easier operation when we're talking about like anything else. But when we're talking about rational functions, multiplying and dividing are going to be the easier of the operations. Reasoning. Since rational is another word for what? Rational, the root word is ratio. Rational is a synonym for fraction, right? Operations with rational functions is the same. This should be R. Operations with rational functions are the same as operations with fractions. Yes, I just changed my handwriting. So it is really important that we understand that, and I'm going to show you how. Operations with rational functions are the same as operations with fractions. So let's talk about operations with fractions real quick. So for something like this, 1/2 times 3/5, I'm going to just multiply across, right? So I get 3 times 1, which is 3, and then 5 times 2, which is 10. It's already simplified. You box your answer. Simple. But then we have something like this. Now, there's two ways we could go about this. We can multiply across and then simplify, which would be 10/6, right? These multiply together, and then these multiply together. But the reason I'm going to show you, and encourage you to do it the other way, a different way, is because 10/6 simplifies to what? You divide both by 2, and you get 5/3. But the reason I'm going to encourage you to do it differently is because when we do rational functions, this is the way that's going to be easier. So you're going to look for ways that we can simplify it within here. Are there any common factors between the numerator and the denominator? Well, yes, we can cross simplify these 2's out. These 2's can cancel out, and it becomes 1/1. So 5 times 1 now is 5, and 1 times 3 is 3, and 5/3 is your answer. Let's try these next two. So we have 4 times, so we could do 4 times 21 and 9 times 26, but 9 times 26, I don't know if you guys know it off the top of your head, but we can cross simplify here. So 4 and 26, what is their common factor? If I had 4/26, I could simplify that by a factor of 2. So I'm going to divide both of these by 2. 4 divided by 2 is 2, and 26 divided by 2 is 13. Then these two, 21 and 9, can be simplified by a factor of 3. If I divide 21 by 3, it's going to be 7. If I divide 9 by 3, it's going to be 3. Now I could do 2 times 7, which is 14, and 3 times 13, which is 39. And then lastly, what if we're dividing? Well, when we divide fractions, we multiply by the reciprocal. So the first thing we're going to do is we have keep, change, flip. For some of you guys learned it like that. Keep, change, flip, or just multiplying by the reciprocal. The 1/2 stays the same. You keep it, you change the division to multiplication, and you flip this to the reciprocal, which is 2/3. And then same rules apply. We're back to the same type of problem. So these 2's cancel out, and we get 1/3. Well, this becomes a 1/1. They don't cancel out. They don't go away. They become 1's. When they completely are the same thing, they become 1's. Okay, so let's actually list out the rules, because I think it's important to identify. Let me write it like this. So rule 1 is to simplify any common factors in the numerator and the denominator, and then multiply across. If you fully simplified, let me zoom out. If you fully simplified before you multiplied across, your answer should already be simplified, but make sure you check in case you missed a step. So what that says is, if you already fully simplified here, this in theory should already be simplified. But let's say you've made a mistake here. You want to just make sure that this is fully simplified. Same rules apply for rational functions. Same exact thing. And also make sure, remember, multiplication, division is multiplication. You just have to flip it. So let's do some problems. So simplify this expression. So we're gonna cross simplify anything that is similar. So let's first look at this. Now, also keep in mind that we can also simplify numerator and denominator on the same side, but we're just going to focus on, we can look, but these don't have any common factors. These don't have any common factors. So we're going to look here. 6c and 8a. Well, c and a are going to stay the same, but 6 and 8 can be simplified, right? So that 6 and 8 are both divisible by what number? They're both divisible by 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. So I have a 3c and 4a, right? So I'm even going to rewrite this just for clarity purposes. So this became a 3c and a 4a. And then over here, what can we simplify? Well, we could simplify 5 and 15. What are they both divisible by? They're both divisible by 5. So this becomes a 1. 5 divided by 5 is 1, and 15 divided by 5 is 3. So this became a 1, and this became a 3. And then C is staying the same because there's no C here. So C is staying the same. And then D. Can we simplify this D squared and this D? Well, yeah, D squared divided by D is what? 2 minus 1 is going to be just 1D. One of the D's goes away. So I take out this D, it becomes another 1. And this D becomes only one of them. So D to the first. So I have a D here, and then we just have another 1 here. So it's 1 times 1, which stays as 1. So now we can multiply across. And so I get 3 times 3, which is 9. C times C is C squared, and then a D. And then we have 1 times 4a, which is just 4a. And there's your final answer. Now, what you can do, if you want, you can multiply across first and then simplify. So I'm just going to show you what that would look like. But even though this looks like a lot of like messiness, I think it saves you a lot of work at the end. So 6 times 15 is, off the top of my head, 15 times 2 is 30, 30 times 90. So 90 C squared D squared over 5 times 8 is 40 AD. So 90 over 40. This happens to be an easy fraction to simplify, which is 9 over 4. And then D squared and D. So you still get the same answer, but not all problems will be this simple. So that's really important. Okay, let's try this one. Now the key here is that we have division, so we need to multiply by the reciprocal. So I'm going to rewrite this: 18xy cubed over 7a squared b squared times, and then we flip, right? We flip this, and so I get, I'll rewrite this like this, times 35a squared b and 12x squared y. We flipped it. So let's do some cross simplification. Once it's multiplication, we can cross simplify. So first thing I'm going to do is 18 and 12. 18 and 12 can both be divided by 6. So again, you want the GCF, the greatest common factor. Yes, they're both simplified by 2, but it wouldn't be fully simplified. So the 18 divided by 6 is 3, and this will be 2. X over x squared, we can take out 1x here and 1x here. If we take 1x here, there's only 1 left, and this stays as a 1. And then y cubed and y, we can take out one of the y's. If we take out one of these y's, we get y. We have 2 left. So this becomes a 1. Okay, next. Let's do the next thing. 35 and 7. Well, 35 is divisible by 7, so 7 divided by 7 is 1. 35 divided by 7 is 5. A squared and a squared just cancel out. just become 1. And b squared and b, we could take away 1b. And if I take 1b away from here, there's 1 left. And so now we can multiply across. And so we have 3 times 5 is 15. 1, and then y squared is left, right? All these 1s don't really matter when we're multiplying. So we have 3, 5, and y squared, which is 15. And then we have b, 2, and x, which is 2bx. Again, it should be already simplified, which it is. All right, let's talk about what happens when we have factors. Arguably easier. So important here is that you have to cross simplify any common factors. Notice you can pick one of these to simplify with each of these. Now, if there happened to be, let's say, this did not exist. Let's say this was not in the problem to begin with. You cannot do this. It only simplifies with one of them if one only exists. But since 2 exist, we can say this cancels out with this, numerator and denominator. This cancels out with this, numerator, denominator. Or even you could just to show. This cancels out with this. And then this x plus 2 cancels out with this. And so what do we have left? All of these are 1s, right? So we have, this is a 1, 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 this is a 1. So I have 1 over what? X plus 3. Final answer. Again, arguably easier, especially if it's already factored. So what happens when it's not already factored? You have to factor it. But again, important that we change it to multiplication. I'm going to factor first. So I'm going to just do all my factoring right here. So we have x plus 4, x minus 4. Again, I'm not doing a factoring review. If you need help with factoring, you're welcome to ask me. But this is not for factoring. So y plus 3. This becomes x minus 6. Nope, sorry. I thought that was a 36. So we have what multiplies to negative 12. This is 8 and 4. X minus 8, x minus 4. And then this becomes this becomes y minus 6y plus 3. So now I'm going to do my keep change flip. So it becomes multiplication, where this stays the same. So we have x plus 4, x minus 4, and then we have 12, y plus 3. And then this is going to flip, right? And this becomes multiplication and flips. So it's going to become y minus 6, y plus 3, and x minus 8, and x minus 4. So now we can do our cross simplification, x minus 4, x minus 4. Y plus 3, y plus 3, and that is it. And then we multiply across. So we get, in my numerator, I have 2 factors, x plus 4, y minus 6 over 12x minus